In this video, we'll be talking about how to solve radical equations. So let's go ahead and look at our first problem. We're going to have the square root of 6 minus x is equal to 4. How would we solve this equation here? Well, let's go ahead and take the first step, which is take the square root of both sides. So when we square both sides, the radical sign and the exponent will cancel out. So we're going to get 6 minus x is equal to 16. Now all we need to do is simply subtract 6 from both sides, giving us negative x is equal to 10. And x is equal to negative 10. So let's go ahead and verify that our solution is going to hold true. So we have 6 minus negative 10 is equal to 6 plus 10, which is 16, which is equal to 4, which does indeed satisfy our original equation that we are trying to solve. So the only solution we are going to get is that x is equal to negative 10. Let's go ahead and look at our next example, which is the square root of 3p, which is equal to p. We're going to square both sides, which is going to give us 3p, which is equal to p squared. Since squaring both sides, the radical sign is going to cancel out, and p squared is simply just p squared. Now we can subtract 3p from both sides, which is going to be 0 is equal to p squared minus 3p. So here, our solution, we could simply just factor out a p. So we get p times p minus 3. Setting everything equal to 0, we get that p is equal to 0 and p is equal to 3. So let's go ahead and verify our solutions. We have the square root of 3p is equal to p. Let's plug in 0, which is going to give us 0 is equal to 0. So we get that p is a solution. So we have 3p, and p is 3, so we have 9. So 3 times 3 is 9, which is in fact equal to 3. So we end up getting that 0 and p are the two solutions to our equation. So let's move on to our next example. And we're going to have the square root of 30 minus x is equal to x. Here we're just going to square both sides, leaving us with 30 minus x on the left-hand side and x squared on the right-hand side. So moving everything to the right, we simply get 0 is equal to x squared plus x minus 30. So we're going to try to factor our quadratic, and here we should end up trying to find two numbers that multiply to negative 30 but add to positive 1. So we have 5 times 6 is 30, and that those two could somehow make positive 1 and multiply to negative 30. So x plus 6 times x minus 5 is going to be our factor. Since if we multiply 6 times negative 5, we get negative 30. And if we go ahead and try to multiply x times negative 5 and 6 times 5, we get 6x minus 5x, which is equal to x. And x times x is simply x squared. So we see that our factor is true and satisfies our original equation. So let's go ahead and now set everything equal to 0, where we end up getting x is equal to negative 6, and x is equal to 5. So we're going to go ahead and see which of these verify our radical equation. So we have x is equal to negative 6. Let's verify negative 6 first. So we end up getting 30 minus negative 6, which is 30 plus 6, giving 36, which is equal to negative 6. The square root of 36 is simply 6, but 6 does not equal negative 6. So x is equal to negative 6 is not a solution to our radical equation. Let's try x is equal to 5. We end up getting the square root of 30 minus 5, which is the square root of 25, is equal to 5. And here we get 5 does indeed equal 5. So x is equal to 5 is the only solution that is going to hold true for our original equation. Let's go ahead and solve a little problem that is slightly a bit more difficult. So we have the square root of 4 x minus plus 8 is equal to x plus 3. So let's go ahead and square both sides. We're simply going to be left with x plus 8 is equal to x plus 3 squared. Here, we have to expand the right-hand side, so we're going to be left with 4x plus 8 is equal to x squared plus 6x plus 9. And we're just using the perfect square property, which is a plus b, so we get a squared plus 2ab plus b squared. So that's how we get x plus 3 squared is equal to x squared plus 6x plus 9. So now here we can go ahead and simply solve this quadratic equation. We're going to subtract 4x plus 8 to both sides, or just move everything on the left-hand side to the right, which is going to give us 0, is equal to x squared. 6x minus 4x, that's plus 2x. And 9 minus 8, which is plus 1, which says 0 is equal to x plus 1 squared. Since if we use the quadratic formula or complete the square, we will end up getting x plus 1 squared is the same thing as x squared plus 2x plus 1. And solving for x, we simply get x is equal to negative 1. So let's go ahead and verify that solution. We have the square root of 4 times negative 1, which is negative 4, plus 8 is equal to negative 1 plus 3. We end up with 2 on the right-hand side and 4 on the left-hand side, which is indeed true. So x does indeed equal 1, or negative 1. Let's go ahead and solve for plus the square root of negative 3x plus 10 is equal to x. So first we're going to go ahead and subtract negative 4 from both sides, which is going to leave us with negative 3x plus 10 is equal to x minus 4. Squaring both sides, we get negative 3x plus 10 is equal to x minus 4 squared. Expanding the right-hand side, we simply get x squared minus 8x plus 16. On the left-hand side, nothing changes, so we get plus 10. All we have to do now is add 3x to both sides. So we get x squared minus 5x and we subtract 10 from both sides, so we get 10 minus, or 16 minus 10, which is positive 6, is equal to 0. We can go ahead and factor our equation, which is going to be two numbers that multiply to 6 and add to negative 5. So the only two numbers that we could possibly think of that could work are 2 and 3. But negative 2 and 3, since they multiply to positive 6 and also add up to negative 5. So we get x minus 2 times x minus 3, where we get x is equal to 2 and x equals 3. So let's go ahead and verify which of our solutions is true and which is an extraneous solution. So we have the square root of negative 3x plus 10 is equal to x minus 4. So here we are going to go ahead and put in positive 2. So here we have the square root of negative 3 times 2, which is 6, or negative 6 plus 10, 4. Since 10 minus 6 is 4, and 2 minus 4 is negative 2. And as far as we are concerned, here we cannot have a solution, since 2 does not equal 2. So x is equal to 2 is not a solution. So now let's go ahead and try x is equal to 3. We have the square root of negative 9 plus 10, which is equal to negative 1. We end up getting 1 is equal to negative 1. 1 is equal to negative 1, which is not true. So here we get two extraneous solutions that none are going to verify our solution. So here we have our two extraneous solutions that won't work for our equation. Now let's go ahead and do n minus 7 is equal to the square root of 3n minus 21. So of course we're going to square both sides, giving us n minus 7 squared is equal to 3n minus 21. Expanding the n minus 7 squared, we end up getting n squared minus 14n plus 49, which is equal to 3n minus 21. Here we're going to go ahead and subtract 3n, giving us n squared. And minus 17n, and we're going to add 21 to both sides, which is plus 70 is equal to 0. So here we can go ahead and try to solve n squared minus 17n plus 70 is equal to 0. So two numbers that multiply to 70 but add up to negative 17. So let's look at the possible factors of 70. We have 7 and 10. Those are the only values that could add up to negative 17 if they were both negative. Negative 7 times negative 10 is equal to 70, but also add up to negative 17. So we end up getting n minus 7 times n minus 10. So here we can now solve for n, giving us n is equal to 7 and n is equal to 10. So let's go ahead and verify both of our solutions, and we are going to verify them. Let's try n first. So we get 7 minus 7, that is 0, is equal to the square root of 7 times 3, 21 minus 21, which is the same thing as 0, so n is equal to 7 is a solution. Now let's go ahead and verify 10. Here we have 3, since 10 minus 7 is 3, is equal to the square root of 30 minus 21, which is the same thing as 9. And the square root of 9 is, in fact, equal to 3, so we end up getting that n is equal to 10 is also a solution. So we do end up getting 2 solutions. Now let's go ahead and solve the square root of 18 minus 3x is equal to x minus 6. So here, what we have to do is square both sides, giving 18 minus 3x is equal to x minus 6 squared. Nothing changed on the left-hand side. And expanding the right-hand side, we get x squared minus 12x plus 36. And we're going to add 3x to both sides, which is going to go ahead and give us x squared. Let's go ahead and look at another problem. And we have the square root of x plus 3 minus 2 is equal to x. We can simply start off by adding 2 to both sides, which is going to leave us with x plus 3 on the left-hand side and x plus 2 on the right-hand side. Squaring both sides, we get x plus 3 is equal to x squared plus 4x plus 4. Subtracting x, we end up getting x squared plus 3x, and 4 minus 3 is plus 1. So we could solve this by using the quadratic formula. Since this quadratic is not factorable, we will get x is equal to negative 3 plus or minus square root of 3 squared, which is 9, minus 4, so which is 5, over 2. So we also get x plus 3, which is the square root of negative 3 plus 5, or root 5 over 2, and 3 is the same thing as over 2. So here we simply end up getting on the inside positive 3 plus root 5 over 2. And we get x plus 2, which is negative 3 plus root 5 plus 4 over 2, which is 4 minus 3, which is 1, plus root 5 over 2. And the value of 1 plus root 5 over 2 is simply 1.618. And on the left-hand side, we have the square root of 3 plus root 5 over 2. And that is going to be the same thing as the right-hand side, so we get 1.618. So we see that x is indeed equal to negative 3 plus root 5 over 2. Now we will go ahead and verify negative root 3 negative 3 minus root 5 over 2. So all we have to do is simply just change the sign on the in front of the radical, which is now going to give us minus and minus. And the right hand side is simply just going to be equal to negative 0.618. And the right hand side is going to be positive 0.618, which is not equal to each other. So we get x is not equal to negative 3 minus root 5 over 2. The only solution is x is equal to negative 3 plus root 5 all over 2. Let's go ahead and look at one last problem. So we're going to have the cube root of x of 3x minus 2 is equal to x. We're going to take the cube root of both sides, which is going to leave us with 3x minus 2 is equal to x cubed. We are going to move everything to the right side. We get x cubed minus 3x plus 2 is equal to 0. Here, we can try and use synthetic division. So we have possible factors, which is plus or minus 1 and plus or minus 2. So we're going to verify if we have one of these solutions as our factors. So here we are going to have one, 0, negative 3, and positive 2. And we are going to test positive 1 out. We drop down 1, multiply it by the divisor, and we get 1, which is just 1. Since we're adding from top to bottom, multiply again by 1. We get negative 3 plus 1, which is negative 2. Negative 2 times 1 is negative 2, and we get 0. So we end up getting the factor x minus 1 times x squared plus x minus 2. And we can go ahead and factor our quadratic and see if we have a possible factor that can tell us our solutions. So we have to find two numbers that multiply to negative 2 and add up to positive 1. And those numbers are x plus 2 times x minus 1. So we are going to get x minus 1 squared times x plus 2. So let's go ahead and set everything equal to 0. And we are going to find x is equal to 1 and negative 2. So we have two solutions where we also have that one is a multiplicity, so we don't really need to list the second one down, so we just get two solutions. So here we are going to verify one first. So the cube root of 3 minus 2, which is 1, is equal to 1. So we see that the cube root of 1 is indeed equal to 1, so x is equal to 1. And for negative 2, we're going to get the cube root of negative 6 minus 2, which is negative 8, which is equal to negative 2. So we see that we get that negative 2 is equal to negative 2. So x is also equal to 2. And x is equal to 1 twice. We're going to put 2m as a multiplicity of 2.